Hello mathematicians, today I'll be covering Chapter 1, Lesson 7, Part 1, Multiply and Divide with Scientific Notation. Our learning objective is I can multiply and divide numbers written in scientific notation. Some vocabulary words for this lesson are product, which is just an answer to a multiplication problem, quotient, which is just an answer to a division problem, product of powers is when we're multiplying numbers with the same base, we can just add their exponents. And the quotient of powers means that when we're dividing numbers with the same base, we can subtract their exponents. I'm going to solve this multiplication problem using expanded form and the product of powers rules. First, if I want to solve it using expanded form, I can write it all out. So 3.9 times 10 times 10. Because 10 to the power of 2 means I multiply 10 as a factor 2 times. Then I'll multiply it by 2.3 times 10 multiplied as a factor 6 times. So 10 times 10 times 10 times 10 times 10 times 10 again. When I multiply the number out front, so 3.9 times 2.3 by each other, I get an answer of 8 and 97 hundredths. Then if I count up how many tens there are, I see that there are 8 tens. So 8 and 97 hundredths times 10 to the power of 8 is my answer. I can also solve this problem using my product of powers rules. So first I'm going to break it into two separate problems. So I'll multiply 3.9 times 2.3, and I know from our previous strategy that it's 8 and 97 hundredths. Then I know that using the product of powers rules, that when I multiply numbers with the same base, so 10 to the power of 2 times 10 to the power of 6, then I can add the exponents. So it becomes 10 to the power of 2 plus 6, or 10 to the power of 8. So my final answer is 8 and 97 hundredths times 10 to the power of 8. It's time to try a little bit of a more difficult problem. So this problem is difficult for two reasons. The first is that when I multiply the number out front by the other number out front, I get a number that's greater than 10. So when I write it in scientific notation, my decimal number has to be between 1 and 10. So I'm going to have to convert and switch my decimal places. And I see that I'm multiplying a positive times a negative number. So when I write it out in expanded form, I'm going to have to switch this exponent to a positive and then turn it back at the end. So let's get started with it. First, I'm going to break this one problem into two separate multiplication problems. So I'll multiply the numbers out front. So 9 and 75 hundredths times 8 and 4 tenths. And I get an answer of 81 and 9 tenths. So this number, 81 and 9 tenths, is greater than 10. So I'm going to have to convert that decimal later. Now I'm going to write out my 10 to the power of 3 multiplied by 10 to the power of negative 6 in expanded form. So 10 to the power of negative 3 would be 10 multiplied as a factor 3 times. So it's 10 times 10 times 10. Now if I'm multiplying 10 to the power of negative 6, I want to write that as a positive exponent. So 10 to the power of negative 6 is actually equal to 1 over 10 to the power of 6. I write it using the multiplicative inverse, and then I change the sign of the exponent. When I multiply 10 to the power of third times 1 over 10 to the power of 6, I multiply 10 as a factor 6 times for the denominator. So 10 times 10 times 10 times 10 times 10 times 10. So I can put this over 1. When I multiply those out, I get 10 multiplied as a factor 3 times in the numerator, and 10 multiplied as a factor 6 times in the denominator. So times 10 times 10 times 10. I can cancel out my tens, and I'm left with 1 on top in my numerator, and 10 multiplied as a factor 3 times in my denominator. So 1 over 10 to the power of 3. And if I convert this back to a negative exponent, it'll be 10 to the power of negative 3. So my answer so far is 81 and 9 tenths times 10 to the power of negative 3. But I have to turn the number out front. I have to change it so that it's between 1 and 10 so that I can write it in true scientific notation. So I'm going to move the decimal to the left 1 unit, so I'm making it smaller. So it's 8 and 1900ths. And so because I made the number smaller out front, I have to make my exponent bigger by 1 unit. So 10 to the power of negative 3 becomes 10 to the power of negative 2, because negative 3 plus 1 is negative 2. All right, so if you don't believe me that that works, that 81 and 9/10 times 10 to the power of negative 3 equals 8 and 1900ths times 10 to the power of negative 2, check it on your calculator. Now let's solve this problem using the product of powers rule, so I'm not writing it out in expanded form. First, I'm going to multiply the numbers out front, so 9 and 7500ths times 8 and 4/10, and I know that equals 81 and 9/10, so I'm still going to have to change the decimal later. And now I can use my product of powers rules to multiply my base 10 numbers. So 10 to the power of 3 times 10 to the power of negative 6 equals 10 to the power of 3 plus a negative 6, which is just 10 to the power of negative 3. So 81 and 9/10 times 10 to the power of negative 3. I have to do the same thing as I did previously, and I'm making my number smaller by 1 unit, so it's 8 and 1900ths. And so I have to make my exponent bigger by 1 unit times 10 to the power of negative 2. Okay, it's your turn. Pause the video, try these problems, and then when you're finished, press play, and I'll reveal the answers. I'm going to start off this problem by turning it into 2 separate problems. So I'll multiply 8 and 4/10 times 2 and 5/10. And then I'll multiply my base 10, so 10 to the power of 2 times 10 to the power of 6. I know that 8 and 4/10 times 2 and 5/10 equals 21. So I'm going to have to convert this later. And then 10 to the power of 2 times 10 to the power of 6, I'll use my product of powers rule, so this becomes 10 to the power of 2 plus 6, or 10 to the power of 8. My answer so far is 21 times 10 to the power of 8. But I need to write this in scientific notation, which means that my number out front has to be between 1 and 10. 21 is greater than 10. So I have to make the number smaller by 1 decimal place. So it becomes 2.1. So I'm making the number smaller by 1 unit, so I have to make the exponent larger by 1 unit. So 2.1 times 10 to the power of 9 is the same thing as 21 times 10 to the power of 8. If you don't believe me, you can check your calculator, but now that number is written in scientific notation. For the next problem, I'll do the same thing and break up this problem into 2 separate problems. So 2.6 times 1.2, and then I'll multiply my base 10, 10 to the power of 4, times 10 to the power of negative 3. 2.6 times 1.2 is equal to 3.12, or 3 and 1200ths. And that's between 1 and 10, so I don't have to convert any of the units later. And now I'm going to multiply my base 10, so 10 to the power of 4 times 10 to the power of negative 3 becomes 10 to the power of 4 plus a negative 3, which is 10 to the power of 1. And I know that any number to the power of 1 is just that number, so it's just 10. So my answer is 3.12 times 10, written in scientific notation. It seems kind of silly to write that number in scientific notation, so this number in standard form is 3.12 times 10, which is 31.2. It's time for a division example. 7 and 7500ths times 10 to the power of 7, all divided by 3 and 1/10 times 10 to the power of 4. First, I'm going to write this out in expanded form. So 7 and 7500ths times 10 multiplied as a factor 7 times, so 10 times 10 times 10 times 10 times 10 times 10 times 10, all divided by 3.1 times 10 multiplied as a factor 4 times, so 10 times 10 times 10 times 10. I'm going to cancel out my 10s, and I'm left with 3 10s in the numerator. Now I have to divide 7 75/100 by 3.1, which is 2.5. So it's 2.5 times 10 to the power of 3. Let's solve this using the quotient of powers. First, I'm going to break this problem up into two separate problems. So 7 75/100 divided by 3.1. I know that this is 2 5/10 or 2.5. Then I can divide my base 10s. So 10 to the power of 7 divided by 10 to the power of 4 is actually 10 to the power of 7 minus 4 because I'm dividing them. So when I divide numbers with the same base, I can subtract their exponents, and this becomes 10 to the power of 3. So my answer is 2.5 times 10 to the power of 3. It's time to take a look at a more difficult problem. So first I'm going to write this in expanded form. So if I have 1 86/100 times 10 to the power of 9, that's 10 multiplied as a factor 9 times. So 10 times 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 10 again. All divided by 6.2 times 10 multiplied as a factor 6 times. So 10 times 10 times 10 times 10 times 10 times 10. Okay, so I can cancel out my 10s. And I'm left with 10 to the power of 3 on top because 10 is multiplied as a factor 3 times. And now I have to find what 1 86/100 divided by 6.2 is. And I see that it's 3/10. So far my answer is 3/10 times 10 to the power of 3. But I see that my number out front isn't between 1 and 10. So to write it in scientific notation, I have to move the decimal place 1 to the right. And because I'm making the number bigger by 1 unit, I have to make my exponent smaller by 1 unit. So when my number out front goes up, my exponent has to go down. So it becomes 3 times 10 to the power of 2. Let's solve this problem using our quotient of powers rules. So first I'm going to break this problem into two separate problems and take 1 86/100 divided by 6 2/10. And I know that from our previous strategy that 1 86/100 divided by 6 2/10 is equal to 3/10. Now I'm going to divide my base 10 numbers. So I know that from my quotient of powers rules that when I divide numbers with the same base, I subtract the exponents. So 10 to the power of 9 divided by 10 to the power of 6 actually becomes 10 to the power of 9 minus 6, which is 10 to the power of 3. So far my answer is 3/10 times 10 to the power of 3. And then I have to do the same thing as above and turn the number out front into a number that's between 1 and 10. So I'm going to move my decimal place 1 to the right. So it becomes 3. And because I'm making it bigger by 1 unit, I have to make my exponent smaller by 1 unit. So it's 3 times 10 to the power of 2. And it seems kind of silly to write this number in scientific notation. So this number written in standard form is actually just 300. It's your turn. Pause the video, give it a try, and when you're ready, press play, and I'll reveal the answer. To begin this problem, I'm going to first break it into two separate problems. So 9 5/10 or 9 1/2 divided by 2. And I know that's 4 75/100. And then I'm going to take 10 to the power of negative 5 divided by 10 to the power of 2. Because of our quotient of powers rules, I know that when I divide numbers with the same base, I have to subtract their exponents. So this 10 to the negative 5 over 10 to the power of 2 is going to become 10 to the power of negative 5 minus 2, which is actually 10 to the power of negative 7. So my answer for this problem is 4 75/100 times 10 to the power of negative 7. Congratulations, you've made it to our funny finale. What did 1/2 say to the other half? Let's make 1 whole. Ha! Thank you for taking time out of your day to watch my video. So long, scholars.